So before we get going, we're just going to talk about what we call our knowledge steps. So what information we're going to use for today, what we're going to be learning, and what we can apply that to in the future. So we're going to be thinking back to some simpler shapes, knowledge of shapes, and finding the perimeters of shapes. Okay, so kind of squares and rectangles and things, we know how to measure those easily, how to find the perimeters of them based on those measurements. But then getting onto circles, circles are much more difficult to measure, right? They're curvy. You can't just use a straight ruler to measure circles. So we're going to be talking about parts of circles that perhaps we can measure. Candy says, yes, perhaps you know some things already about this. So we'll get onto that a little bit later in the lesson. So looking at what we can measure on circles, and then ahead. So in the summer term course, actually, in the middle of term, we'll be looking at starting to find the areas of circles as well. But if we have a circle, we need to think about what parts of the circle we perhaps can measure easily with a ruler, so that we can then kind of work out what we can measure from there. So I've got a diagram of a circle here, and I'm going to talk to you about 4 different aspects of a circle that we can identify and measure. So the first one is what we call the center of the circle. Okay, so every circle has a point bang in the center. It's labeled with an O in this diagram here. So that's the center of our circle, right in the middle. And then the second one is what we call the diameter of the circle. Okay, so what a diameter of the circle is, it's kind of like the width of the circle. It's the length all the way from the top of the circle to the bottom of the circle, or from one side to the other. But the important thing is it needs to be a line which goes through the center of our circle. Okay, so for example, this line that goes from A to B, okay, it goes through the center, A, then through the center, and then to B. That is a diameter of the circle. Okay, and we can draw a diameter. Do you know what can be measured? Yeah, so we can draw a diameter wherever we like, as long as it's a straight line from one side of the circle to the other, which goes through the center of the circle. Okay, so all of these lines I'm drawing at the moment, these are all going to be diameters of the circle. And the reason why it's fine for those all to be diameters is because wherever you draw it, it's going to have the same length. Okay, so as long as your line goes through the center of the circle from one side to the other, that will be what we call a diameter. And then the next thing I'm going to tell you about is the radius of the circle. So what the radius of the circle is it's any line which goes from the center of the circle to the outside of the circle. Okay, so I've drawn an example radius on there for you. And like with the diameter, we can draw it wherever we like, as long as it's a straight line starting at the center of the circle and going to the outside. Okay, so just like with the diameter, wherever you choose to draw a radius, it will have the same length, and that's why it's okay to call it the radius wherever we draw it. And then the last thing we're going to talk about on a circle is the circumference. Okay, circumference of a circle, it's basically just a fancy word for perimeter. Okay, but only for circles. So the circumference is just the distance all the way around the circle. Okay, so if we start, for example, at the point A, we walk all the way around the outside of the circle and finish back at A again, the distance we would walk around the circle would be what we call the circumference. So just like a perimeter, but for a circle. Okay, so if I go on to the next slide, we've got a summary of those bits of information on here for you guys. So again, the circumference is the distance all the way around the circle. Then a straight line that passes through the center of the circle and connects 2 points on the circumference is called the diameter. So that's just something to be aware of. Sometimes we refer to the circumference just meaning the outside of the circle. Okay, so the circumference on its own just means the distance around the outside. But we can also talk about a point being on the circumference, meaning just a point on the outside of the circle. So the diameter, just a line which goes all the way through the circle, through the center. And a radius is just a line which goes from the center of the circle to the outside. Okay, good. So on to this next slide then. So we've got our two, I think, Academy mascots on this page. They're called Pip and Bud, for those of you who haven't met them yet. And Pip is asking, in this diagram here, is CD a diameter of the circle? So the line going from point C to point D, is that a diameter? Okay, what do we think? I'm going to let you guys vote on this now. So you can vote true if you think it's a diameter, and false if you think it's not a diameter. Okay, good. That's a few of you. I'm going to give you 5 more seconds for anyone who hasn't voted yet. 2, 1. Okay, good. So CD is a diameter of the circle, okay, because again, it's a line which goes through the center of our circle and it goes from one side to the other. Okay, so it's a diameter as long as it goes through the center and goes all the way from one side of the circle to the other. And then Bud's just telling us here, sometimes you'll see this odd-looking word radii, R-A-D-I-I, and that's just the plural form of radius. Okay, so radius, it's a Latin word. It has one of these funny plurals where it just has an I at the end instead of an S, or radiuses or something. Okay, good. So with that in mind, we're going to start to look at perhaps measuring the diameter and the radius. Leon's learning Latin, that sounds good. We're going to look at measuring the radius and the diameter of some circles and seeing if we can spot how they might be related. So I've got 3 circles at the bottom of the page here, circles 1, 2, and 3. And those of you, some of you might have this printed out. You can try measuring them yourselves as well. And you might get some different results depending on what size of paper, I suppose, you've printed these on. But all we've got to do, right, is draw a diameter. So I'll highlight in red the diameters that have been drawn on each of these circles, these long lines across the center. And then in green, I'll show you the radius, or the radii, rather, the plural of radius, which have been drawn onto these circles. And each of these have been measured. I've put the results I've got in the table here. Okay, so if you have a look at those, see if you can spot how they might be related. I think Candy has perhaps spotted something. Would anybody like to come on screen and tell me what the relationship is here between the radius and the diameter? Okay, hello, Leon.
The difference is between the radius and the diameter is like the radius times 2 equals the diameter.
Okay, excellent. Thank you for that, Leon. That's absolutely right. I'm going to take you off there now. So we can spot for each of these 3 circles. For circle 1, if you double the radius, you get the diameter, and the same for circle 2, the same for circle 3. Okay, and it kind of makes sense when you look at the diagram, right? If you look at a diameter, a line which goes all the way across the circle, well, if you split it in 2, then each half of the diameter, right, is the first half will go from the outside of the circle to the center. So that will be a radius. And then the second half, again, that will go from the center to the other side of the circle. So that will also be a radius. So it's kind of easy to see once you think of it that way, that the diameter has got to always just be 2 times the radius. Okay, so with that in mind, we're just going to fill in the blanks on this next page here. So we've got this sentence, the diameter of the circle is blank its radius. So can you guys all think about what word should maybe go in that first blank there? Okay, and tell me in the chat once you've thought of it. I'll unmute the chat, so you should be able to type in the chat now. Okay, excellent. Leon says double. That sounds good to me. So the diameter of the circle is double its radius or twice its radius. Either of those would be fine. And what about for the second one? So the radius of the circle is blank its diameter. What do we think should go in that second blank? Okay, Candy says half. That sounds good to me. So if you halve the diameter, you can then get back to the radius. So we're going to say the radius of the circle is half of its diameter. Okay, excellent. So without further ado then, let's have a go at some questions based on this knowledge. So we know now that the diameter is always just double the radius, or the other way around, the radius is just half of the diameter. So we've got a couple of circles here that we're going to find the diameter or the radius, depending on which one we already have. So the first question, we're told that the radius of this circle is 5.1 centimeters. As you can see, is labeled on the diagram there, 5.1 centimeters. And then we want to find the diameter. Okay, so can you guys work out for me what the diameter would be? I'll give you perhaps another 10 seconds to work that out. And once you've got your answer, if you just put that in the chat and see what everyone gets. Okay, nice. I can see 10.2 centimeters. 10.2, looks like everyone's in agreement. So, of course, the diameter is just double the radius. 2 lots of 5.1 is going to give us that 10.2. And then for the second one, we're given that the diameter is 13 centimeters. What would the radius be? Okay, if the diameter is 13, what's the radius going to be? See, perhaps Bella's already done this second one. Anyone else? Candy as well. Yep, so I'm seeing some 6.5s. That sounds very good. So 6.5, just half of 13. So if we've got the diameter, just halve it to get the radius. Okay, excellent. So now that we're happy with that, the diameter is always just twice the radius, we're going to look at some slightly more complicated questions. So this diagram I've got here, those of you who can see, we've got a rectangle with 2 circles just fit snugly inside it. Again, we can see the radius of the circles is 4 centimeters. That's been labeled on for us. And we want to find out what the length of the rectangle is and also what the width of the rectangle is. Okay, so if we start with the length of the rectangle, so going all the way across, let's see, would anybody like to put their hand up and tell me how they think we might find the length of this rectangle here? Okay, hello. Is it Pratyusa?
Yes. We would find out the diameter of one of the circles, which is 8.
Okay.
And then we just double it to do both of them.
Okay, excellent. Thank you very much for that, Pratyusa. I'm going to take you off there now so I can write that up on the board. So we can spot that the distance, the length all the way across the rectangle, if we draw that in, say, the middle of the rectangle, then it's just going to cut across both of the circles through their centers. And so the overall length of this rectangle will just be made up of 2 diameters, 2 circle diameters. Okay, so like Pratyusa said, a diameter is just going to be twice the radius. 2 times 4 is 8 centimeters. So both of the circles will have that diameter of 8 centimeters, which will give us an overall length of 2 lots of 8, or 16 centimeters. Okay, good. So we're halfway there. And now we just want to find the width as well. So let me clear up all of that extra stuff I've drawn on there. We're now going to find the width, or kind of like the height of this rectangle. Okay, what do we think the height might be? You can see some people have perhaps found height already. 8 centimeters, that's absolutely right, 8 centimeters. So again, we know the diameter of the circle is always the same, whether we draw it horizontally, vertically, diagonally, however we like. And the width of this rectangle, well, we can see that if we draw it through the center of one of these circles, then one diameter of a circle is just going to be the width of this rectangle. So we get 8 centimeters for that. Okay, excellent. So with that in mind, I've got a slightly more tricky one to have a go at here. Would anybody like to read out this question to the class? Put up your hand if you'd like to come on. Okay, Candy.
The 4 circles in the diagram each have a diameter of 4 cm. Touch the sides of the rectangle and pass through the center of at least one other circle. What is the perimeter of the rectangle?
Okay, excellent. Thank you for that, Candy. Well read. So we're going to try to find the perimeter of this rectangle. So again, like the last one, we're going to need to try to find the length and find the width. The length in this one is going to be a little bit more tricky because we've got these kind of overlapping circles. As we had read out, they're kind of going through each other's centers. Okay, so each of these points where the circles meet each other is the center of one of the circles. Okay. Would anybody like to come on and suggest to me how we might find the length of this rectangle? Okay, Leon, what do you think?
So there's so the first circle on the left to the point where the two circles meet is like the radius of a circle.
Okay, yeah.
So that means if that is the radius of a circle, then all the points that meets together is also the radius of the circles.
Okay, excellent, very good spot. Thank you for that, Leon. I'm going to take you off so I can label that on so everyone can see that very clearly. Thank you very much for that suggestion. So what Leon has spotted is that each of these distances that I'm labeling in red here, so from where circles meet to the next point where circles meet, they're all just going halfway across a circle. Okay, so each of these is going to be one radius of a circle. Okay, and can you guys tell me in the chat, what is the radius of each of these circles in this diagram? So if you have a look back to the question, we're told the diameter. What is the radius of one of the circles? Okay, excellent. So the radius is going to be 2 centimeters. Okay, and we can see that the full width of this, or the full length rather, of this rectangle, all the way along it from left to right, is made up of five lots of the radius. Okay, so we're going to get 5 times 2, 10 centimeters is the width. And then we just need the height, and then we can find the perimeter. Okay, so the height is going to be very similar to the last question. It's going to be 1 diameter of the circle. So perhaps I'll leave you guys to make sure you know what the height is for yourselves. And I'm going to give you some time on the timer. And once you've worked out the final perimeter of this rectangle, you can vote for what you think the correct answer is. So we've got A, B, C, and D. So we've worked out the length of the rectangle was 10, and then the width of the rectangle is going to be 1 diameter of the circle, which perhaps we're told what that is in the question. And then I just want you to find the perimeter. So the correct answer for this one was C. So well done to those of you who got that. So the width of this rectangle, right, just 1 diameter, that's going to be 4 centimeters. And then it's just finding the perimeter of a rectangle. So we've got 4 centimeters by 10 centimeters. The perimeter, remember, we can just do 4 plus 10 and then double it. Yes, thank you, Candy. That's absolutely right. And we get that answer of 28 centimeters.